Welcome to Pradeep sir classes as BSc, where Logo can talk the physics students. And students, obviously we are in IIT Foundation course ICSE-10 Work Energy Power Kinetic Energy lecture number 7 chapter number 2. So students, for today's class, the main goal is we have to know the expression for kinetic energy and the relationship between the momentum. What is about momentum? There is mass and velocity. Obviously क्या लेना पड़ेगा? Momentum मतलब mass और velocity का product लेना पड़ेगा. So what is the relationship between momentum and kinetic energy? And the third one is work energy theorem, and obviously the last one is forms of kinetic energy. So what are the different forms? सोचो कि एक ऑब्जेक्ट है और वो मोशन में है और सीधा जा रहा है, मतलब the kinetic energy possessed by the body when it is confined to be moved in a particular direction, that is translational kinetic energy. अगर कोई ऑब्जेक्ट अगर घूम रहा है मतलब दिस इज इन रोटेशनल काइनेटिक एनर्जी, और व्हेन ए बॉडी इज इन वाइब्रेशन, दैट इज a body is in vibration, that it possesses vibrational kinetic energy. So for today's after the completions of these classes, we are able to know about the different main key problems or key topic 1, 2, 3 and 4, the expression, the relations, work energy theorem and the forms of kinetic energy. So students, if you are still you have not subscribe my channel, then please subscribe and go for that particular class. Okay, so let's start with the class. And the first of all, you have to know the definition of it. So the what is when a energy, when a body possesses kinetic energy or potential energy. Students, you can think that when an object we can change the configuration, and ये fruits अगर यहाँ पर है मतलब इस configuration में क्या है ना, change आए हुए है, position में change आ गया, मतलब when a object is kept at a particular height, then it possesses kinetic moment, potential energy, that is mgh. Okay, and when the body is in motion, then it possesses the kinetic energy. So what is about energy? The energy possessed, write down a note, the energy possessed, the energy possessed by a body, the energy possessed by a body due to its state of rest or motion. स्टूडेंट सोच लो कि कोई ऑब्जेक्ट अगर रेस्ट में है और मोशन में, मतलब इट possesses some energy. So when the energy possessed by a body due to its state of rest or motion is called mechanical energy, is called mechanical energy. Mechanical energy. So the first question is, what is mechanical energy? The energy possessed by body due to its state of rest or motion. कोई ऑब्जेक्ट अगर स्टेट में है और कोई ऑब्जेक्ट अगर मोशन में है, मतलब a bullet is just moving with a particular velocity, that is a bullet is fired from a gun, it possesses kinetic energy. So the bullet is obviously is in motion, and if we change the state of this, if we placed this particular chalk at some height, then it possesses potential energy, that is mgh. So the energy possessed by a body due to its state of rest or motion is called mechanical energy, and this mechanical energy is of two types. That is, first of all, it is kinetic energy, and the second one is potential energy. So students, मैकेनिकल एनर्जी जो है वो टू टाइप का है. दैट इज काइनेटिक एनर्जी. वन इज काइनेटिक एनर्जी एंड इट इज and you can denoted it by k, only k, and the potential energy, that is potential energy, and you can also write as kinetic energy. Okay, so the energy possessed by a body due to its rest is called potential energy, or change in configuration, or we can say that change in configuration. That is change in configuration. Change in configuration. Okay, and the energy possessed by a body due to its motion is called kinetic energy. So first of all, students, you have to write three definitions. What is mechanical energy? First question is what is mechanical energy, and the second one is what are the different forms of mechanical energy, and you can also write as define kinetic energy or define potential energy, and give an example for each of the following. So first one is the energy possessed by a body due to its state of rest or motion is called mechanical energy, and the second one is what are the different forms of it, that is the different forms of it is kinetic and the potential energy. And what is the definition of kinetic energy? The energy possessed by a body due to its state of rest, this is called potential, and due to its motion is called kinetic energy. Okay, and give an example for each of the following. So a bullet fired from a gun is an example of kinetic energy, and this chalk is kept at some height from the surface of the earth, then it possesses some energy that is called potential energy, and it is we have to write as the expression is for that particular one, it is half mv square. The kinetic energy is half mv square and the potential energy is mgh due to its configuration, change in configuration. Okay, and the energy unit of energy is joule for kinetic energy as well as potential energy. So the SI, what is the SI unit of energy? Then you can write as joule. Joule is the SI unit, and arc, ERG, arc is the also a unit. I already discussed what is the relationship between joule and arc. If you first in that particular class, then go back to the previous one and enjoy the classes and then again come back. Okay, so the next one is what is kinetic energy, and a qualitative value of the kinetic energy that we can describe as, and we can derive for particular equation related to kinetic energy. So what is kinetic energy? Next question is what is kinetic energy, and derive an equation for it. So students, write down the equation. What is kinetic energy? What is kinetic energy? Derive an equation for it. So what is kinetic energy? And students, kinetic energy क्या है? और you know that the equation is kinetic energy का जो equation है वो क्या है? Half mv square. So you have to derive that particular equation. So what is kinetic energy? And you can write the definition. The energy energy possessed by a body due to its state of motion. State of motion. So the energy possessed by a body due to its state of motion is called kinetic energy. And the next one is derive an equation for it. That is, you have to derive kinetic energy equal to half mv square. So the students think that an object is moving with some velocity v. So let an object or a body object is moving with a velocity v. So this is the initial velocity. हम लोग स्टूडेंट्स क्या लेते हैं, इनिशियल वेलोसिटी मतलब u और फाइनल वेलोसिटी मतलब v, मगर यहाँ पर कुछ स्पीड में तो ऑब्जेक्ट है ही पहले से, so you can take it as v. So let an object is moving with a velocity v, and if you want to stop that particular one, if you want to stop that particular body, that is the final velocity will be 0. So then you have to some work on that particular body. So let an object is moving with a velocity v, and due to the application of some forces, due to the application of some force against it, due to the application of some force against it full stop, it stops after traversing a distance, a distance s. So let an object is moving with a velocity v, and due to the application of some force against it, it stops after traveling a distance. So जो students एक object move कर रहा था, okay, and due to the application of some force against it, it stops after describing some distance. Okay, so the distance traveled by it is, so the distance, therefore distance traveled by, if it is s, then you can easily apply the equation v square equal to u square minus 2as, and here minus is due to the retardation. So the final velocity is 0, but the initial velocity is v, so you can write as 0 equal to v square minus 2as, or s equal to v square by 2a. Here v square equal to 2a. Okay, so v square, here this is the initial velocity, and here the initial velocity is v, as we take that the body is moving with the velocity, and due to the application of some forces against it, the velocity is 0. So 0 equal to v square minus 2s, or s equal to v square by 2a. Okay, and so the work done to stop the particular body. So work done to stop the body. Then students write down the work done. So the work done. So the work done. So the work done on it. On it means on the body. So work equal to force into displacement, and force, students, we know that force equal to mass into acceleration, and here the displacement s is v square by 2a. and A cancel this one, so half mv square amount of work is done on the body, and this work done is called a kinetic energy. Okay, this work is equivalent to energy, so this is kinetic energy equal to half mv square. So students, from this discussion, we know that a body, when it is in motion, then it possesses some energy, and if we stop that particular object, then you have to apply some forces against on it, and the body is stopped. For doing this, you have done some work, and this work is called kinetic energy. So kinetic energy equal to half mv square. Again I repeat, what is mechanical energy, what are the different forms? There is kinetic and potential energy. What is kinetic energy and what is the expression for it? Okay, and the next one is, I think the next one will be, that is the relationship between the potential, the relationship between the momentum and the kinetic energy. So P equal to momentum. So the equation is P equal to 2 root over of 2m into kinetic energy K. So students, write down the question. What is the relationship between the momentum and what is the relationship? What is or you can write that, prove that P equal to root over of 2m and K, where P is the momentum. Momentum means linear momentum, and K for kinetic energy. Only we can write here as K. Okay, so what is the relationship between momentum and kinetic energy? So students, first of all, for doing this, you have to know what is momentum. So students, write down the definition. Momentum, M-O-M-E-N-T-U-M, momentum. So momentum is the product of mass and velocity. Momentum क्या होता है? Momentum is only you have to multiply मास के साथ जो वेलोसिटी है बॉडी का. कुछ वेलोसिटी में तो बॉडी मूव कर रहा था, मतलब मोमेंटम हो जाएगा मास इनटू वेलोसिटी. जस्ट यू हैव टू टेक अ प्रोडक्ट ऑफ मास एंड वेलोसिटी. ओके, सो द मोमेंटम इज, इट इज द प्रोडक्ट ऑफ, इट इज द प्रोडक्ट ऑफ mass and velocity. So it is P equal to mv, and it is a vector quantity, so you can write as P vector equal to m into velocity vector. So vector is, that is, possesses magnitude as well as direction. So what is about velocity? Velocity is a speed plus direction. क्या होता है? स्पीड के साथ अगर डायरेक्शन जुड़ जाए तो हो जाएगा वेलोसिटी. मतलब कुछ मैग्नीट्यूड है फिजिकल क्वांटिटी का और इन अ स्पेसिफिक डायरेक्शन. सपोज योर मॉम से यू दैट you have to move 3 steps along this direction. So you cannot take 3 steps like 1, 2, 3. You have to take the steps as 1 and then 2, then 3 in a specific direction. That is simply, it is a vector quantity. So what is momentum, students? Suppose this is a chalk and it is at rest. So there is no momentum. If I throw along this direction, then it possesses some energy because it is in motion. So momentum is the product of mass and velocity, and the kinetic energies, and the second one is kinetic energy. This is equal to half mv square. So you have to relate the two physical quantity, that is momentum as well as kinetic energy. That is, it takes the form like that, P equal to root over of 2mk. सो क्या करना पड़ेगा, जो मोमेंटम जो है और उसके साथ जो मोमेंटम के साथ जो काइनेटिक एनर्जी है कोई बॉडी का, बॉडी तो मूव कर रहा है मतलब उसके साथ मोमेंटम जुड़ा हुआ है as well as the kinetic energy. So you have to relate the two physical quantity, there is momentum and kinetic energy. Okay, so let's start. That is kinetic energy equal to, or you can write as K equal to half mv square, half mv square. And students सोचो कि m है और एक m के साथ मल्टीप्लाई कर दिए यहाँ पर, so you have to divide it with another m so that this and this one cancel and this is remains like that half mv square, isn't? Okay, so kinetic energy equal to half m square v square, you can write as m square v square by m, or mv means momentum, so p equal to mv and p equal to mv, so mass, this is p square by m here and this is k, so p square equal to you have to take a cross multiply, and देखो स्टूडेंट्स क्रॉस मल्टीप्लाई करके क्या मिलेगा 2m और यहाँ पर k है, so p square equal to 2m k, और you can write as p equal to root over of 2m and the kinetic energy, and the relation is proved. So what is the relation between the momentum के साथ जो काइनेटिक एनर्जी का रिलेशन क्या होगा, p इक्वल टू रूट ओवर ऑफ 2mk, एंड बहुत ही बढ़िया एक्सप्रेशन है ये, एंड डिफरेंट न्यूमेरिकल्स भी है एक्सरसाइज में, सो लेट्स ट्राई विथ दैट पर्टिकुलर वन, एंड फॉर दैट you have to know another theorem, what is that is work energy theorem. So the next one is work energy theorem. Work energy theorem. So पहले तो इसका डेफिनेशन लिख लीजिए आप लोग, वर्क एनर्जी theorem. What is work energy theorem? According to the work energy theorem, लिख लीजिए आप लोग, according to work energy theorem, according to work energy theorem, the work done by a force, 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 according to work energy theorem, the work done by a force on a moving object, on a moving body, on a moving body is the change in kinetic energy, is the change in kinetic energy. So work energy theorem, according to work energy theorem, the work done by a force on a moving body. So to students, there is a moving body and it is moving with a velocity u, moving with a velocity and its mass is m, and you can think that this is a velocity v. So a body is moving with a velocity, एक body है और body का mass क्या है m, और body जो move कर रहा है उसके साथ जो velocity related है वो है v, so half m square, therefore the initial kinetic energy, and you can write as kinetic energy and suffix I. So kinetic energy initial, this is equal to half m square, and you have to apply a retarding force, or you can apply suppose think that this is u. Okay, so this is the initial kinetic energy, and if you applied a force along this direction, then its velocity, obviously its velocity क्या होगा, चेंज हो जाएगा, so इसका velocity हो गया v, and mass, it is a constant value, so it is m, and the final kinetic energy is F equal to half m u square, half m, this is u square, and this is v square, sorry, this is v square. So this is the final kinetic energy. Therefore you can say that work done equal to kinetic energy final minus kinetic energy initial. So this is work energy theorem. Work energy theorem. So according to work energy theorem, the work done by a force on a moving body is the change in kinetic energy. Change in kinetic energy मतलब एक बॉडी के साथ जो वेलोसिटी जुड़ा हुआ है और उसके साथ रिलेटेड जो काइनेटिक एनर्जी, उस काइनेटिक एनर्जी में क्या डिफरेंस हो गया, काइनेटिक एनर्जी का डिफरेंस क्या है, जितना डिफरेंस है उतना ही वर्क डन, work is done on that particular body. Okay, and this the amount of work is done on that particular body. Okay, let's prove that theorem. Work done. So proof of work energy theorem. The next topic is proof of work energy. So prove it. Prove the theorem. So let's consider a body is moving with, consider a body moving with initial velocity u. Let's consider body of mass, लगा लीजिए यहाँ पर mass तो है ही body का. So let us consider a body of mass small m and moving with a velocity u, and due to the application of force its velocity become v. So इनिशियल वेलोसिटी एक बॉडी का, ये मास का कोई बॉडी है, उस बॉडी के साथ जो इनिशियल वेलोसिटी है वो u है, and due to the application of some forces its velocity becomes v, and this is u, this is mass, and due to the application of some forces its velocity becomes v, and the mass remains m, and it traverses some distances a. So v square equal to u square, and if it is accelerating motion, so this is s, and s equal to v square minus u square by 2a. So distance equal to, students, s equal to v square, then you have to subtract this one u by 2a. So this is the distance covered due to the change in kinetic energy, since this is an accelerated motion. So the work done is, work equal to force into displacement, and force equal to mass into acceleration, then s equal to v square minus u square by 2a. And you can think, you can see that in place of f you can write mass into acceleration, and in place of s you can write v square minus u square by 2a. So a and a cancel this one, and you can easily write as m into v square minus u square, and this is 2. So half m v square minus half m u square, half m v square minus half m u square, and you can write that work done equal to kinetic energy final minus kinetic energy initial. So this is proved. So this is the work energy theorem. On what is about work energy theorem? When a body is moving and you do some work to change, you do some you have to apply some forces, and the velocity changes with particular intense, and the change in kinetic energy, this is exactly equal to the work done by you. Okay, so this is work energy theorem, and the next one is different form of kinetic energy. So different form of kinetic energy. What are the different forms of kinetic energy? Different forms of kinetic energy. So first one is translational kinetic energy. Translational kinetic energy. And the second one is rotational kinetic energy. Rotational kinetic energy. And the third one is vibrational kinetic energy. And these are the three types of kinetic energy. As students, when an object is confined to move in a straight line, then it is called translational motion, and the energy possessed by the body during translational motion is called translational kinetic energy. When a body is moving with a circular path, then we can say that this is a circular motion, and the energy possessed by the body when it is in circular motion, then we can say that this is rotational kinetic energy. And when a body is in vibration, then we can say that the body is in vibrational kinetic energy, or we can say that the energy possessed by the body during its vibration mode, and that is called vibrational kinetic energy. So give an example for each of the following. Example number 1, and that is related to translational motion. A gun, a bullet fired from a gun. A bullet fired from a gun. And the 2 for the rotational motion, it is spinning top. And the third one is vibration. A vibrating string. Vibrating string. The string of the guitar, or you can write as a string of the guitar. So these are the example of different forms, that is translational, rotational, as well as the vibrational kinetic energy. And thank you for that particular class, students. And last of all, I want to say subscribe, share with your friends this channel if you think that this is the best educational platform for you. Okay, so thank you, and last of all, continue your study. Okay.